Do we have slides where we put the entire?
No.
Should we do that, or do you want to just pull up the PR when we're?
That's the only thing I want to actually show. I think.
Yeah. Okay.
I think that's the only operative bit. Everything else is basically a no op.
Yeah, people were complaining about that. So make a no.
Yeah. Start. And give it a minute or two. Get started. Good morning. Okay. Good morning, everybody. Congratulations for getting through the week and making it this far. We're going to get started. So those of you that are not yet in Meet Echo, please do join to make sure that we get a room bigger than a shoebox next time. I see about 8 people in there, and I count slightly more than 8 people in the room. I imagine many of you are well familiar with this by now, but if this is your first meeting of the week, if you're just joining us for the day, then please make sure you're aware of the IETF Notewell and the conditions under which you participate in this meeting. In terms of the agenda today, we're going to spend a chunk of time just talking about the recharter and gathering some feedback there. We do not strictly need to use all of that time. We'd be very happy to get it back. But if there are things that we need to talk about and feedback we need to hear, it would be great to get that out and discuss that in person. And then we have presentations from Yaroslav on the DNS draft, and then 2 new drafts to be discussed. In terms of the status of the working group, congratulations to the authors, because Ethernet, UDP Listen, QUIC Proxy, these are all ready to go to the IESG. They've completed their working group last call. And the indication from IPDNS is that we're very nearly there, as well, as we'll hear later in the presentations. Tommy?
Hello, Tommy Polly, Apple. This is a question from the authors of the QUIC proxy draft. We just wanted feedback for the status there, right? Because the document is and like was originally adopted as experimental. We just wanted to confirm, is that what we want to have it be? As we were talking with people who had like done the hackathon work on it, implementations, they're like, it kind of feels like we actually deployed this at scale and we have based this on like actual engineering work. It could be proposed standard. I don't think we have a particularly strong opinion, but we'd just like to get feedback, because this moment when we're doing the Shepherd write-ups and everything is like, that's the right time to make sure it has the right status. So would love to hear your feedback and anyone else's feedback.
Yeah. Yeah, Mira.
Mia Kuhlevin Eriksson. Yeah, I think actually it's a good point. I think it's well tested, even partly deployed. So there's no reason for experimental, and that would make it easier. Just go straight away to proposed standard.
Marcus Hiller just came up to say exactly the same thing as Mirja. I think there is no reason to keep this one as experimental. We have interop experience, there's deployment experience. Just let's make it proposed standard.
Yeah. Yep, that sounds good. We'll confirm that on the list, but that seems pretty sensible.
There are two questions in the chat. What is the experiment? And the second question is, how confident are we in the crypto for that dog?
That's a good point. So for the experiment, that's kind of the point now of like what is the experiment, because I think we had a bit more of an experiment before of like, will this work, or like will it actually help on efficiency, and like I think we've done the experiment now at this point, so it doesn't need to be. For the crypto bits, I think that's an interesting question. Like, I'm not a cryptographer, so I'm not in a position to be, to make grand statements there. But I think when we interpret what we have, the work we've done and the analysis we've done in terms of the goal of trying to obfuscate and scramble, I think as far as we know, and based on the work we've done, which I think has been, we've had a pretty good analysis there. It is achieving that goal. I think the goal of that obfuscation is probably a lower bar than some other things where like, oh, this is trying to be the base encryption or authentication for any particular flow. But I'd be curious if people have opinions on what other bars they would like to see cleared. But I think it's in a decent state there for what it needs to be.
Lars Eggert, Mozilla. So if we have question marks around the security properties, I feel uncomfortable making it a proposed standard. However, maybe we can ask the security area for an early review and tell them, like, here's specifically what we would like you to comment on. And if we get a security review that says this is all right, I would feel much more comfortable.
Yeah. I guess just to contextualize the question marks, I think it's more that in this particular goal, because it's about how good are you at preventing traffic analysis, and the whole notion of like traffic analysis is a bit more in the researchy area for like what are all the defenses there, that it's just a harder thing to evaluate. I think for obfuscating and saying this is unpredictable data, I think yes, we can say it is unpredictable data. Beyond that, like how do you do all the right things, because like we've kept it out of scope to say padding and timing attacks, so that's where it gets complicated. I'm not sure any review of sector will be like, yes, this is, you cannot say this is impervious to the whole solution into traffic analysis without a lot more work.
Right, Lars Eggert. So given that the answer is we are confident there are no issues, but a lot more words that I'm still trying to pass through. I think it doesn't hurt to ask them, right? But I think if it's researchy and if we don't know, and maybe then the status is actually accurate, because we can always revise it later, right? But that's just me, and I'm going to sit down after this. Like I would feel more comfortable if we had somebody who knew this area tell us that they think it's okay, or if they can at least sort of like point out the issues that may exist, and then we can decide, is this something that we believe is okay for a proposed standard or not?
Mia Kühlewind. First of all, I think it's very good to have a security review, but this is kind of the next step anyway, right? So we are behind working group last call, so it will go into IETF last call, and we'll get security review. So I don't think it makes a difference. Okay. We did a lot of analysis around this, and I think described this very well, what the properties are of this protocol that you get or don't get. And there's always an easy way out. This is an optimization. If you have a scenario where you want to make sure you have the best security you can get, you just don't use it. You use old school MASQUE tunneling and whatever. But I think a lot of these analyses, which are more researchy, are actually around proxies in general, because the question about how you can map traffic and anonymize in a proxy scenario or whatever, there's like a ton of research to do there. And this just adds a different angle to it. So I don't think this is more researchy than all the other questions we have in this space.
Martin Duke Google. I don't know what style it should have, but if we do keep it experimental, I think we should write down in the draft what the experiment is, whether it's like we want more penetration testing, or we want, some sort of, we expect, we think it's possible attacks may develop against this, or whatever, or something else entirely. There should be words in the draft about that, which I was not able to find by a very quick skim, if those exist.
That's good feedback.
Antoine Sancourt, Huawei. As far as I remember, when we were working on security considerations for in the design team for MASQUE, we ruled out attacks related to traffic timing and traffic analysis, and we focused on providing the formal header structures that would allow someone willing to have packet padding and traffic timing to protect against an external observer, to have the tools to have those security measurements. But structurally, if you look at the header, we made sure that no information, no metadata could be used to obviously track the packet from one end to the other. So this is what I remember. And I agree that traffic timing attacks are more on the research part of things. There is a wealth of literature about such attacks for system selector, etc. Maybe this is something that we can write a draft about if you are interested.
So I don't see Mike in the room, so I thought I might talk. Is Mike here? No. Okay, fine. Spencer's in the list. Spencer first. Go for Spencer. Spencer, please.
Spencer?
Yeah. I wanted to say I understand the concerns about traffic analysis. That sounds to me like we're worried about an arms race, which is not a bad arms race to be worried about. Would that threat prevent us from recommending deployment at scale? And I think a reasonable question for me to ask at the same time, is this better than what people have as an alternative for deployment today?
Take Dennis first.
No, I'm at the back, so after you.
So I was going to talk about the experimental versus PS, and one of the concerns I would have is if we don't try and list the experimental a little bit more clearly now that we're trying to address, then we won't clearly be able to articulate to SAG or whoever's going to do the security review what it is that we want them to confirm. So let's be clear about this, because this is a difficult area, because there are Tor, there's HAPI, there's a whole load of technologies in this space that do tunneling and proxying, and we're not trying to mimic that, we're trying to do something else. So we've got to say clearly what we're trying to achieve here and ask the security director what to do. But if we are intending to take this forward as PS, perhaps, then we should tell them that before we do the review. So don't start a working group last call saying, hey, we're experimental, please give us a security review, because the review you get will be lightweight and won't be good enough for doing a last call for a PS. So please decide and ask that question to sector, is this good? Yeah. Well, okay, well, even if we do a working group last call, well, yeah, okay, right, but we do a working group last call as EXP, yes? Exactly. So that's what I'm motivating here. I'm saying the working group should decide that they think the experiment is done and this is what the experiment was, and therefore they would like to take this forward as PS and try it.
Okay, so if I can, I think, from no hats at this point, but it doesn't sound like we're doing an experiment. I think we're confident enough in this thing that we want it to be proposed standard. And I actually don't think that there's a different standard for security between those things. I think it's got to do that it needs to achieve the property that it claims to achieve. And it might be we need to do some wordsmithing there to make sure that's clear to implementers. But I think that's something that can be done sort of in conjunction with SEC review. So that would be my proposed way forward, to assuming we have consensus, change the status, and then to get those security reviews and make sure that those issues, if any, are addressed properly. Okay, so we also have some proposed work that's coming into the group that we'll hear from later today. Just as a reminder, we've discussed the MASQUE proxy sort of architecture document at previous meetings. There was a general consensus that we would like to adopt such a document, but it's not currently in charter. So we are going to try and re-charter to include that document. We have two talks later today on the compression and ECN. And then it's been discussed informally, something along the lines of a QLog related draft. And we'll discuss this in a second because nobody's concretely put such a draft forwards. So in terms of the rechartering, the motivation is essentially twofold. One, we want to bring that architecture document in scope. And two, we want to start to sunset the working group. MASQUE was always intended to be a short-lived working group, and it's been 5 years, so relatively short in IETF time. In terms of how we do that, we've put up a PR that's been available only this week, but really the core change is moving from like open to various extensions to scoping it down to these 8 items. The first set are ones that we've already adopted and are working on, and we're just in the process of finishing up. They are staying in the charter scope in case the IESG bounces them back, and we need to do some more work to finish them. We have the informational architecture document in point 5, and then these remaining 3 are very much conditional on the working group wanting to adopt them. So these may or may not remain in the text, depending on the working group's decisions. And in terms of how we do this, we want to get the feedback from folks in the room today, if there is any. We want to run those adoption calls, then we'll finalize and recharter at that point. So it's very much adoption calls, then recharter, rather than the other way around. So do folks have anything they want to raise, anything they want to flag at this point? Any concerns about this approach or these decisions?
Trying to get in the queue. Maybe, yeah, now I'm in the queue. Jahid Shakir. So the process I saw, like that this is, you want to adapt something that you are not chartered to do?
No, sorry. So we can't consider the informational architecture document until we recharter.
Yeah,
So
I mean,
that
the process in the next slide you saw, like, okay, run the things, run adoption call for what?
yeah, sorry, that would
None
be,
of these are on the charter. Like some of these are in charter, like the architecture document.
yeah,
We cannot adopt with this without rechartering.
no, sorry, so this would be for ECN for the compression draft
Okay.
and the QLog draft if somebody
The
puts one
extension you
forwards.
can extensions you
Yes.
can adopt.
Yeah,
But
the architecture document
architecture
is to one
document,
side for now.
Okay.
But it is something we've talked about in the previous meetings and sort of had a hum in favor of, but there's
Yeah,
been
I
no
mean,
consensus.
My suggestion would be like, let's have the rechartering discussion and see like the all rest of the thing falls into that one. I mean, there
Sure.
is no point of like calling for adoption and then rechartering to make them stick there. I think if you were talking about rechartering, let's recharter, think like we want to work with this, and then recharter and adopt those things. And you can do rechartering adoption at the same time if you want to. So process-wise, that would be clear to me. That's what I'm saying.
Okay, no, that's helpful. Thank you.
Hello.
Hello.
Yeah, I gave some feedback on GitHub overnight. Like the way this was laid out was just super confusing for me because half of those things are nearly done and like ready to go to the ISG, at which point they're kind of not really a working group thing anymore. And the other half are brand new stuff I don't know anything about. Yeah, it just seems like we couldn't make this a lot clearer by not mentioning the current things and actually rephrasing the intent or the desire to work on the other stuff that's listed there, which might make it more clear. Like, what is the things we want to work on? What is the measure of success that can mean that we can conclude the working group once those things are delivered or not delivered because we went through the process of establishing working group consensus, and at some point maybe we failed and decided not to work on that anymore.
Okay, Lucas, just very briefly on the inclusion of the existing work. An earlier draft actually removed it, and the feedback we got was that could be dangerous in the event it does get bounced back by the IESG. Hence, we included it. But yeah.
Martin Duke. So if I understand correctly, there are 4 new work items here.
Yeah.
Okay. It's not up to me, I suppose, but my guess would be that if we were to shut down the group, that maintenance of these documents would pass the HTTP BIS. Is that a reasonable assumption?
There's various places it could go,
Okay.
right? I guess
All right,
QUIC
fair enough.
or
Well,
area or,
so my point is, if there's actually energy to do 3 or 4 new items, I think yes, we should recharter for those 3 or 4 items. If there's energy to do 1 or 2 of them, particularly if they're one they're frankly sort of niche like QLog, I think it would be better to shut the group down and go to whatever inheriting group and run a couple drafts through HTTP BIS or TSVWG. As TSVWG chair, I don't think it's the right place, but maybe it is. I don't know. It's up to an AD. But I think with just 1 or 2 documents, there's not going to be enough energy in the room, and we should just shut it down and go somewhere else. Thanks.
Tommy Pauly. I agree with Lucas's comments. Just reading through the charter, I would encourage us to not do the editorial cleanups and fixes to earlier paragraphs and stuff. Like, I agree the text looks better, but like it just raises questions of like, why is it changing? And like, having seen the side where charters have to go through approvals and stuff, it's going to be a lot easier if it's like really minimal and it's like very clear at the diff. For the point of listing previous work items, again, ask your friendly neighborhood AD, but I think we could essentially say anything that has been currently adopted and like is progressed is still in scope. Like, you can do something without having to like list out all of the individual work items. Yes.
Quick AD interrupt on that. When you send the charter to the IESG, if you decide to want to make one, then you have to include the milestones. So it's obvious what work you're doing. Exactly. This is irrelevant, really. Right. There'll already be milestones, and there might be milestones for things you propose to do next. Either way.
Thank you. Yeah. I think the milestones is a better way to handle this.
Great.
For Martin's point, I think the architecture document is its own little beast. But for the other ones, I think, well, and I'm not sure about QLog, but for the other two in the middle, I think they are useful because of the precedent they set, that they are extensions here that are looking at how do we do things that want to improve efficiency or add tweaks, and they raise questions about the composition of extensions, which is something that from the very beginning when we were doing capsules has come up, and it exercises that point. And I think it is worth doing at least enough of that so that when other groups get to maintain these things, it is clear the right pattern, and we've worked out the kinks in how we do the extensions. Because these topics are not new. We've talked about them since the moment we talked about anything in Connect UDP and Connect IP. So the desire to do them isn't going to go away, and we should figure out how to do them. But we should make it clear that once we have figured out how to do them, and then someone comes along in 2 years and wants to add another little IP packet marking, that they don't have to do it here, that there's a formula that they follow. That heck, maybe even is just like you need something in an IANA registry with expert review, and you don't even need to go through a whole working group process.
Okay, thank you, Tommy. So I think that's pretty useful feedback. We'll probably follow this up on the list, I think, rather than further discussion here. Yep. Okay, so I think we have Yaroslav up with DNS.
Good morning, everybody. My name is Yaroslav, and on behalf of myself and David, I'm presenting today DNS configuration for proxying IP in HTTP, except now it's called DNS and Pref64 configuration for proxying IP in HTTP. For those who might not attended previous IETF meeting or forgot, we discussed if Pref64 information should become a separate micro draft or micro specification, or be added into this micro specification, and rough consensus, as far as I recall, was that we are adding it into this specification, so it has a little bit more substance. So again, quick recap, this is not a new way to transport DNS or perform NAT64. That is just signaling a mechanism to share between peers what are DNS resolvers available, and also information about Pref64, that is what IPv6 prefix should be used for 624 translation. The changes from previous revision, we've changed the scope of the draft. We changed the title, but we kept the name for consistency. Added new Pref64 capsule. Similar, its design is very similar to Pref64 from RFC 8781, which tells how to discover Pref64 in routing advertisement. The only difference there is we don't need to do anything about lifetimes. We have the luxury of reliable transport for this information, so we don't need to artificially expire them or whatever. You can, at any point in time, send a fresh one if you want to update information about Pref64 prefixes. Multiple Pref64 prefixes may be included in a single capsule. Again, unlike routing advertisement, we have flexibility of being as great capsules as long as we'd like. And Pref64, if you want to remove Pref64 prefixes that you've advertised previously, you like want to stop doing NAT64 translation, for example, you can just send an capsule with an empty list of pref64 prefixes, invalidating previous prefixes effectively. This is what our proposed pref64 capsule is. So very straightforward, just length and a number of NAT64 prefixes. Each prefix comes with prefix length and prefix. One interesting gotcha here is that prefix is always 96 bits, and prefix length specify offset where you want to inject IPv4. This is a little bit weird. Most people do 96-bit prefix length, but we are told that there are some exceptions to that. There are some people who do non-96-bit prefixes, and still, since other specifications of 64 translation allow such a thing, we follow it. We don't want to introduce additional restrictions that don't exist in other specifications, even if they open up use cases that are seldomly used. And by the way, down there, it's a table from RFC 6052 that tells how to add IPv4 address into your IPv6 prefix depending on prefix length. It's a little bit non-obvious for myself at least. We refer that as normative reference in our document. So with that, we are working, David and I are working on our own prototype implementations. We would like to do a little bit of interop before formally calling for working group last call, but we feel that we're very, very close to working group last call. Anyone else is interested in interop exercise for DNS information signaling and or pref64, please do reach out. We'd like to try this out, even though they are fairly straightforward specifications. Would be great to have actual experience before going to working group last call. Any questions, suggestions, comments? Lots of enthusiasm. Thank you.
Very good. Yeah, and I think we've got Yaroslav again.
Yeah. Am I good to go? Okay. All right, now to something slightly less obvious. Reusable templates and checksum offload for Connect IP. I've got quite a bit of feedback since I've put together this draft. At the end, I will share some interesting pieces of feedback that I've collected, but this presentation is primarily about mechanism that is defined in a 00 draft as was submitted before the deadline. So this proposal brings in effectively compression for Connect IP to help with some of MTU pressures, and also allows endpoints to avoid layer 4 checksum, TCP UDP checksum calculation for IP packets. So let's look into why and how. So there are two challenges with Connect IP that I have discovered when I was doing my experiments. One, very obvious MTU pressures. So if you're sending Connect IP over public internet, you don't have luxury of 1500 MTU. You have lower MTU because of overhead, because of encryption tag and all these things. And the more pressure on MTU you have, the more constraints you have on the underlying protocol. So saving some bytes in MTU always helps, especially if you have some kind of weird internal protocol that is not necessarily flexible in terms of MTU that it is comfortable with. And secondly, I discovered that in certain environments, and again, I'll come to that in just a moment, there is non-trivial amount of CPU time lost computing TCP UDP checksums, and that would be great to avoid this if TCP and UDP checksums are not necessary. So let's first go into reusable templates. So there are many sections of packets that are identical of all packets in a given flow or in majority of packets in a given flow. So things such as IP version, IPv4 header length, traffic class, TTL hop limit, and so on and so forth, they are identical. So would be great to not transmit them over and over and over again. So the idea is that sender could identify those segments. So on this illustration, they are highlighted in orange. Signal to the receiver that yes, those are packet segments that will be the same in some packets. So I'm defining a new context ID. I'm not going to transmit those segments in datagrams that are associated with given context ID. I will just send you those deflated, so to speak, packet with the segments missing, and then it will be your job to reassemble the packet, insert those segments based on the offsets that I tell you so. One of the benefits of this approach, well, obviously it's quite flexible. It doesn't have a hard binding to any properties of IPv4, IPv6, TCP, UDP, or whatever, so you could use it for multiple purposes. Potentially, you could compress stuff in layer 7 if you wanted to. So, for example, if you know your length of connection ID, or if it's QUIC inside UDP, you could do some interesting creative things as long as you're careful. And also on the receiver side, you don't really need to have any knowledge of underlying packet structure. You just follow the algorithm to reinflate the packet. Lars?
Yeah, hi, Lars, I got Mozilla. I probably have a very stupid question, so I apologize. So why does this need to be a protocol mechanism rather than just running like a compressor on the packet stream?
So the reason why it's not using existing IP header compression, there are two reasons.
Or any compression.
Yeah. So first of all compression mechanisms that I looked into so far, they are in-band. They follow the same datagram. So in our case, we would have to implement them inside the datagram. We have in Connect IP rather unique luxury that we have two channels. We have reliable channel. Well, in case of HTTP3 QUIC, where you have separate datagrams, we have reliable channel where we send capsules and define context. And then we have so-called forwarding channel where we send datagrams where we would like to deflate packets. So that's the primary reason why it's a separate protocol level mechanism. It's better because we have reliability, so we don't care if there is any packet loss on the datagram side. We have, again, reliable stream where we define these things. The whole operation becomes much more predictable. Okay.
Yeah.
Martin?
In response to Lars, a generic compressor in this would leak information potentially by the size of packets. So that's something that's potentially worth considering. This sort of arrangement doesn't have that because it's fixed chunks. So that's good. Question for Yaroslav. Is there a limit on the number of segments that the setup has? Can you dynamically set that?
The current proposal doesn't have a limit on number of segments, but it have a limit on number of templates that the party is happy to maintain at any given time. So when this capability is negotiated, one party could signal to another, hey, I do support templates, and I'm happy to keep up to, let's say, 20,000 segments, 20,000 templates concurrently, meaning that you have some protection against misbehaving peer who would define arbitrary number of templates. Do you think that we also need to define a limit of individual segments, not only templates?
I think you probably do. If you have a 1200 byte packet, it would be really unfortunate if someone sent you 600 segments, and it just increased the cost of forwarding. So you probably do want something.
Okay, thank you. That's good feedback. Okay, so Right, notes about templating. I think I covered most of these things. It's up to sender to decide how to split the packet. So again, receiver doesn't need to worry about parsing IPv4, IPv6, or whatever. It's again down to sender to be smart about things. Support of templates is announced by each party separately. So you could have one party supporting it and another not. So when you declare that you're supporting it, that means that you can receive context definitions accordingly and templates, but you're not going to you're not going to send them if the other party is not supporting them. And if you have one-of-a-kind packet that is not falling into the template but part of the same flow, you always can use context ID 0, so it's not going to go away. So again, if you have some kind of packet with urgent TCP or unusual combination of things, somehow TTL changed, then you can always either define a new template or use context ID 0. And multiple templates can be defined in a single packet flow, so nothing in the specification that requires you to have just one template per flow. So you can have multiple if that's what you want to do. So the next one is slightly less obvious, is TCP/UDP checksum offloading. So some personal story. So when I was building my first prototype Connect IP implementation, I ran into a very hard limit of 5.5 gigabit per second. So no matter what I did, I couldn't get above 5.5 gigabit per second per core. After scratching my head for a little while, I figured out that the issue was in tunnel, Linux tunnel interfaces, because each time you collect a packet from tunnel interface, you do a syscall, and you typically cannot do more than 500,000 syscalls, so 500,000 packets per second, roughly 5.5 gigabit per second. And a potential solution for that is to use GSO on tunnel interfaces. So with GSO, you get those packet trains, you get large artificial packets that you have then to slice yourself, but you save on the number of syscalls that you're doing. But when you do that, you lose checksums. So you have then to compute TCP and UDP checksums yourself on your process level before you send traffic in Connect IP. So once I've implemented that, I've significantly increased performance. That was great. But looking at flame graphs, figuring out where the next performance bottleneck is, I figured that I'm spending about 5% of CPU time computing checksums, which is actually quite a lot in my book. So, and that's actually on relatively convenient x64 and ARM64 architectures that have add with carry operation that is very, very efficient for computing internet checksums. And there are other platforms such as RISC that might not have this operation and will have even more performance punishment if they have to compute TCP UDP checksum. So taking a step back in summary, TCP UDP checksum. So what are the situations when you may need to compute them yourself in software? So first of all, if you have process originating a flow, sending data to you, you're picking it up on the same host, encapsulate that in Connect IP, encrypt, do all the things, and then send out. Well, there is no network interface card where you can offload TCP UDP checksum calculation because the original non-encrypted packet does not cross network interface card. So you have to do that inside your process, or kernel would do that for you, but kernel would still do that in software, wasting some CPU cycles on doing that. And the second is what I've described. If you're working with TON-TAP interfaces on certain operating systems, on Linux, for example, there are certain situations when you need to negotiate with a kernel not to give you TCP UDP checksums, so that will enable other optimizations such as generic segment offload on the tunnels. So meaning that in order to send correct packet in Connect IP, you do need to calculate TCP UDP checksum yourself in the user land. And then on the receiver side, similarly, you don't always need checksums, right? So if you are delivering packets from Connect IP into local process, well, you have all the wonders of strong encryptions in QUIC, so you don't really need TCP/UDP checksums to check for packet corruption. The QUIC layer does that for you very, very effectively. So you can just hand over data to the process. Again, if you're working with TON-TAP interfaces on operating systems like Linux, where you can say that, yeah, I'm giving you packets without TCP/UDP checksum, that's okay. And then if you're some kind of a router or a bridge where you then encapsulate packets from Connect IP and give them to a NIC, then again, most NICs these days support TCP/UDP checksum offload, so they will be very happy to compute TCP/UDP checksum for you as long as you provide them with correct offsets where to place the layer 4 checksum. So common way to signal checksum offloading, I did not really find a good normative reference for that. I'm still looking. So the only piece of kind of somewhat normative documentation is Linux kernel documentation, but in my experience, that's process that is used pretty much everywhere in exact same way. So once you agreed with your kernel or NIC driver or whatever that you're okay with omitting TCP/UDP checksums, then you still compute TCP/UDP checksum of the pseudo header. So layer 3 header with a very small pseudo header with protocol number and length. And you have you need to provide a metadata structure. Again, it's operating system specific, where you specify where the checksum offset is and where the data begins for computing of the checksum. So the resulting process will run internet checksum calculation over the data and will insert correct checksum into a given offset. That's, again, in my experience, that's very common mechanism how all network interface cards and TON-TAP interfaces and other places signal checksum offloading. So the proposal is to introduce an optional capability in Connect IP to do this kind of checksum offloading. So when receiver doesn't really need checksums and when sender doesn't want to provide checksums, would be great to save CPU cycles on both ends. So now, while these mechanisms, the templating and checksum offloading, they're kind of separate and solving two separate problems, they both define potentially context ID. So that's why, as of this version of the draft, I'm proposing a single capsule. Right now, the placeholder name is IP optimization crate that defines a context ID, has a length of, has static segments in that, and optional fields for checksum field offset and checksum start offset if we're doing layer 4 checksum offload. So the structure of static segments contains list of segments. Each segment has an offlet length and the payload. Segments must be signaled in order and they must not overlap. So, and there are headers defined how would you signal support of these capabilities. So, Lars.
Hi, Lars, I get Mozilla. So it's been a long time since I did something with IP checksums, but there is a way to recompute it based on the binary differences between two things. Can you not apply this here?
This is exactly what is happening here.
Okay,
so
all right. Sorry.
You're still sending checksum of the pseudo header and offsets. And then the receiving party, either in software, if they don't have anything to offload to, or they just propagate this information.
No,
to
that's
NIC.
not what I mean. So when you have the full IP packet and you have a checksum, because you're like a router, it comes in with the checksum, and then you take chunks out. You can recompute the checksum by adjusting for the things you took out of the packet.
I'm not sure if I fully understand.
So you don't need to recompute the checksum over the remaining bytes. You can adjust the existing checksum based on the binary difference between the original packet and the new packet.
Right. So the checksum, this mechanism is not about static templates. Okay. It's about that one party does not include checksum of the whole packet. It includes only checksum of the pseudo header. And
Okay.
the receiving party again
check them-
ideally uses Onico float or something.
All right.
Yeah. So yeah, that's, and I know that's confusing. Sorry about that. Again, the reason why I'm proposing that as a single draft is because both of these mechanisms define context ID, and it makes sense to create context ID as a part of a single capsule, but I'll discuss that in a little bit. So potential future development based on initial feedback. So one piece of feedback was that this mechanism, or at least that templating mechanism or compression mechanism, could be useful not only for Connect IP, but for pretty much all the places that use datagrams. So for example, Connect UDP, maybe Connect Ethernet. You could obviously compress away your MAC addresses and other things in the same way if you wanted to do that. Now, though the question is, how do we combine this with ECN DSCP context ID? So one problem that I want to avoid, obviously, if you have multiple mechanisms that define context ID and you do those mechanisms at the same time, you can potentially end up with packet corruption. So if you have one capsule defining context ID and another adding some more information about the same context ID, you have packet arriving in between, then you have incomplete information what that context ID means, meaning that potentially really bad things could happen. So there are two potential approaches that I believe we could explore. One is to have a kind of unified capsule that defines context ID, and all the things that contribute to that context ID comes as TLVs within that capsule. The second option that was proposed by David Skenazy is to have every capsule that defines context ID takes as one of the uses another context ID as kind of parent. So if you, for example, defining a capsule that would do checksum offload that defines a context ID, it could take as one of parameters a context ID of a previous optimization, such as compression, for example. So yeah, but that's obviously still to be defined. But it would be great to have something that would allow additional optimizations that could be added in the future. For example, IPv4 checksum compression. So current mechanisms that are proposed here do not allow for that because IPv4 checksum is not static. It changes because your packet length changes, and it's very easy to compute. This is something that some parties, I'm sure, would like not to transmit and save 2 additional bytes on the MTU. So that was quite a bit of material. Any thoughts, suggestions, comments? Lauren?
Yeah, the first one that came to mind was could this templating feature be able to be used to explode the size of messages for an amplification attack type thing?
So I guess that goes back to the comment that Martin made. It would be great to limit number of elements in the template that could be defined to mitigate that. But well, these contexts are defined in capsules on the control channel, so to speak. So I don't think there is a big risk here.
Well, if the chunk is a certain size and the identifier is a smaller size, then the input would be smaller than the output.
Not sure if I follow. Let's take it offline. Thanks.
Actually, we have the real scenario. I try to figure out whether this is going to work or not. Because we have actually the 3GPP had introduced a feature called MASQUE based on.
Sorry, which feature?
Some feature based on this technology using Connect IP, Connect UDP things. The problem now is for the session IP. So basically the very high level IP and going to talk through the proxy to the final things. But the things for that feature is going to have two passes between your, we call from the terminal equipment to the proxy, or we call it's like a router, we call the UPF, and through multi-path QUIC. So we are going to allocate 2 pairs of IP addresses. Okay, the UE on the terminal equipment, you're going to have 2 IPv4 or IPv6 addresses. On the UPF side or the proxy, you're going to have another corresponding. It's like totally 4. Now the total in cap so far is like you have a session IP, and depend on some URSP user rule selection something URSP, it's going to select one of the multipath MP QUIC paths. So in that sense, you have like a reusable template say something are identical, like IP addresses. Actually, what I'm looking at, it may not be identical since you have 2 paths. So see, you have some packet, right? You have the session IP and supposed to talk to the server part through the proxy. But on the encapsulation stack, it has to go through one of the MP QUIC paths. That is going to have its own IP, either on the first path IP or the second path IP. So that's not identical,
So
that scenario, I don't know how it's going to work.
This is about compressing of things that are encapsulated in QUIC datagrams. As far as I understood you, you're talking about multipath QUIC that is above that.
It's not exactly the payload part, because I'm looking at the slide 4, the segment things.
Right. So this is covering a packet that is encapsulated inside Connect IP.
Okay. Yeah, go ahead.
As a multipath author, I don't think there is any dependency here.
Okay, let me think about it. Or I can talk to you offline.
Okay.
Yeah, that is a feature has been standardized in 3GPP for 5G already. Yeah, I don't know whether it's going to get impact. Yeah, thank you.
Actually, yes, we use MASQUE in this extension in 3GPP, and we really, really want compression for Connect IP there. Yes.
Right. So if this is perfect. I don't see a reason why this would not be compatible with multipath QUIC or any other things that you're doing on QUIC layer. This is within datagrams that you may send however you want.
Okay, sure. Thank you.
All right. Thank you.
Mia Kuhlevin Erickson. And this was pretty much what I wanted to say. Thank you for bringing this here. Thank you for talking about your implementation experiences and the performance impact of that. I think if we actually want to make Connect IP deployable, we need to look into compression. I think there's a broad space of like how generic you want to be about this, how simple or complex you can do things. But I think we should start the discussion here and figure out where we want to be in that space.
Great. Thank you. Gori?
Gori, as an individual, wondering how much you've looked at things like SHIC and the large number of different IP header compression technologies which Inter has been working on. Have you looked at those already, or are they something to come?
Yes, I spent quite a bit of time looking at those, implemented some of those in my past life. The kind of architectural difference between existing compression schemes that they are all about compressing in-band. So you are oblivious to encapsulation or messaging or whatever you have, because most tunneling schemes that exist today, they do not have this lovely multiplex property that we have in Connect IP. Here we have a separate channel for sending data reliably, in an ordered fashion, and then as a best effort, so to speak, fashion, we're sending those datagrams. So I did not see any existing technology that would be able to effectively leverage this lovely property.
Okay, but the follow-up is, are the techniques similar that you're going to use here so that when we come to find new things we want to compress, we already have other places to pull that from? Or are we going to form a whole body of different documents to compress new things that we're going to find?
Right. So I think one of the benefits of this proposal is it's not bound to any specific property of IPv4, IPv6, TCP, and UDP. It's up to sender to decide what are the repeating segments in whatever is being encapsulated on whichever layer it happens to be, and transmit it over. Now, when it comes to other optimizations that could be defined via context ID, for example, checksums. So somebody could say that, hey, I don't want any checksum at all. I want the receiver to recompute a pseudo-header checksum and then negotiate with their NIC in their own way. Could be perfectly valid. So we need extensibility to the specification. Again, I see two potential paths, either this cascading of context ID, so somebody defines a new context ID and refers a previous one, inherits all the optimizations from that context ID, or a more generic TLV capsule that have all the optimizations aligned in one thing, and both parties would need to negotiate via headers what they're going to do.
Okay, thank you. I'll read the draft.
Thank you.
Eric Rosenberg, Apple. First of all, thank you for putting this together. It seems promising, particularly the MTU win. I did have one question about the templates concurrency. I noticed that you're expressing that in a header and there's like a fixed concurrency limit. Did you consider doing something a little bit more offset based to avoid like rapid reset style registrations and removals?
Interesting. So do you foresee that one party could somehow abuse another party by defining context and removing them, this kind of attack?
Yeah. So we had something similar in the QUIC proxying draft where we register forwarding rules and remove them. And that's the path that we took there. So if you had thought about it.
I have not, and yes, let's connect offline. I'd be very interested to learning more about this potential vulnerability.
Yes, there is an acknowledgement on the in that case too, but the client can like close it, can do the registration and close like in quick succession. So that.
Oh, by the way, the current draft does not have acknowledgement capsules, and that's a mistake on my part that is going to be fixed.
Thank you very much.
Marcus Hilar, Ericsson. So first of all, I also want to thank you for doing this work. I think this is a really nice design, and I think we should move in this direction. You did mention, like, I really like this design with the static and dynamic segments, but you did mention, I think, that there are a few fields that are dynamic but easy to compute that you might want to offload. Is this something you would want to consider in this extension, or is this something that you would like to do in like separate specific extensions for specific fields? Like there are a few length fields and such that you could consider, for instance.
Right. I think it's worth having all the reasonable things within one document instead of having explosion of all sorts of micro compression documents, if that's your question. But yes, I'd be very interested in collating all those use cases and defining a scalable mechanism in one document. So things that come to mind are obviously IPv4 checksum field, yes, various length fields. And again, there are fundamentally two ways how you can do TCP UDP checksum offload. You either still pass over the pseudo header checksum, or you omit it completely and let the receiver do computation of pseudo header checksum. Both are, I think, valid approaches, and some would prefer others versus one versus another. So this is something that we should specify.
Thank you.
Thank you.
Okay, thank you for that discussion. That was useful. Do you want us to run a show of hands on whether people have read the draft and would support
Of course,
it?
yeah.
Okay, so we're going to ask, first of all, just whether you've read the draft enough to have an opinion on it.
I also vote yes.
Okay, so just for the minutes, that was only relatively few people have read the draft at this point. I think on the basis of that, we're not going to ask the follow-up question yet. And we're going to let folks have a chance to digest that, and we'll follow up on the list.
Sounds reasonable to me. Thank you.
Thank you for the presentation. Okay, and finally, we have Magnus to talk to us about ECN and DSCP support. Oh, sorry, Mira.
Probably should have told you that I'm presenting.
Yeah, sorry.
No worries. Yes, so Magnus presented this last time, actually, and we can go to the next slide. Should I take the clicker?
The clicker works.
And what happened since last time is mainly we had actually 2 drafts last time. So now Martin Seaman joined as author, and we did some minor updates because mostly clarifications, renaming, talking about congestion control in a different way, and also fixed the mistake we did about client-initiated context IDs. But we didn't make any big changes because we really want more feedback from the group about what we should do here. A quick recap, what we define is actually 2 extensions. One is what we call ECN 0-byte extension. So here we just use 4 different context IDs to signal or to give the information about which ECN field or ECN code point you should put into the IP header. And so you don't you just choose the context IDs, you signal them, and you don't have to put any other data than the payload into the datagram. And then the other option, which provides you both ECN and diffserv support, actually adds another byte to before the payload that puts the information in there. Yep, so these are the 2 extensions. And then for each of the 2 extensions, we have also 2 ways to provide the information to you. Either you can do it within the HTTP header directly at the beginning, or you can use a capsule, which is useful if you want to actually provide additional context IDs later during the connection. But in the kind of easiest use case, like when you use ECN 0-byte header, you provide the 4, or actually 3 context IDs, because the 0 you already have at the beginning, and you're done, and you don't have to do anything else. So we found it still useful to have the header because that's kind of the common case. But then there are also a couple of cases where you more dynamically want to signal that, and that's why we kept the capsules as well. This is the issues we would like some feedback. Lars, yes.
Last I got Mozilla, I was still shocked by the combinatorial explosion here. So it seems like we're using more options than bits to encode, which is sort of slightly worrying. So can you can we narrow this down? Can I not need to implement 17 different variants to encode?
You can just not implement it, yes.
No, but what if, I mean,
so
it's good to be exhaustive in exploring the design space, but maybe at some point before we publish, we can that narrow on some.
I mean, I totally with you, right? So we had a discussion about should we remove the header, but I mean that's actually what you want in most cases. And it's like if the overhead is really having a slightly longer document, which is not very long, it's actually short, and then you have the choice, and you can just do whatever is right for you. I don't know, but input is welcome, definitely, absolutely. No, but different opinions, right? So, this discussion we just had, we were also wondering if it's valuable to add an egg frame here. In the capsule case, actually, the thing that you gain from getting an egg frame is you actually know that the other one has the knowledge, and so when you then start sending after you got the egg, you know that your packets or your capsules, no, your datagrams, what are the terms? Your datagrams don't get dropped, they don't get delayed or whatever. So, it's a certain benefit you get from it, but it's really a generic question for kind of all the extensions we do, I would say. Is it a good pattern to always have these acknowledgement capsules or not? Go to GitHub and put some comments in. This is a issue about should we use headers or not. We have an issue. You can put some comments in there, Lars. But if there's further feedback, I'm happy about this. And then the third issue is actually the big one we would like some input on. And it's also a little bit a generic case because there are various ways how you can extend or how you can combine different extensions. Because the context ID is used to like provide you an extension, but what if you want to use the ECN extension and the comparison extension, or the ECN extension and UDP listen? Like, how do you combine these things? And there's currently one way that's proposed in the draft, which is basically you, in your capsule where you announce your context ID, you also announce something like a following context ID. And then that just means that kind of you chain your extension if you, I will go into detail. The other one is you could have multiple context IDs in the packet itself. So that would, for each extension you have, you would like add another context ID, and that would like add additional bytes to every packet you send. Or you can actually define these combinations and then like for all the combinations use a different context ID and single all these context IDs. So that's even more explanation. So what does it mean? So option 1 means you have the context ID 0, which is just the UDP payload. And then, for example, you have the proxying bound UDP and HTTP extension, which would add an address, and you assign context ID 2. And then if you want to combine these two, you assign context ID 4, and you just say before the payloads, you actually have two fields. One is the address, and the other one is a diffserv point. Or if you just want to use diffserv byte, then you define another context ID 6 in this case, and that's only this one. So that's how you can use, and that means you have to, in the assignment of the context ID, you somehow have to tell that this context ID covers both this context ID and kind of the other context ID that also has the address. That's what we have currently in the draft. So the other option is the one where you put the context ID into the packet. That would look like this. You always have one context ID, and then in the case of the UDP listening extension, you have the address field. And if you now want to add the DSCP field, you just add another context ID in another field, and you have another context ID in another field, whatever. So that's another option. And then the last option is basically this. You only have one context ID, but you really have to single and define everything separately in your draft. Yes, please.
Right, and then of course you may want to combine context IDs with other extensions that define context IDs, such as that I just presented. It feels to me that option 1 is by far the most scalable, extensible. However, I think that it would make sense, instead of when you define a context ID, to also tell, hey, and there is another one coming, if I understood how it's currently defined correctly, do other way around. Define context ID and always have a parent context ID. So if there is no parent, you say it's context ID 0, that's a parent. And if you inherit properties of another context ID, you specify what context ID was the parent. Does that make sense?
What's the difference?
The difference is sometimes you don't know which optimizations are you going to define later down the line.
But you can, it's just about chaining, just like the question is just like how you, at the end, how you, in which position you put the additional information in the thing here.
Right, I was thinking of chaining of context IDs with other reasons to the context ID. So for example,
so
templates.
The context ID might not add a field, that's true. But it can anyway apply, yes. You just say, this is the next context ID, or the previous one, it doesn't really matter. I think it's just like, there is a next one, and the next one could just point to another one and whatever, and you keep chaining them, right?
I don't have that strong
It's just
opinion.
like, you have to make sure everything can work together, right? If you like have two different extensions that defines two different compression methods, you cannot probably use them together.
Correct, that would be logical error. But then, again, from like protocol processing perspective, it feels to me that looking up at a previous context ID and a future context ID is more natural.
In this one, the context IDs are in the capsule. So you just that once, and then you know how to pass the packet, always in the same way. This one is where the context ID is in the packet.
Yep.
maybe it makes a difference there. I don't know.
Okay, okay,
Yeah.
let's connect offline.
Tommy, Polly, Apple. I think I generally prefer 2 because it avoids some of the ordering and negotiation issues. It allows more flexibility for what gets negotiated when. So like, I don't know, you can imagine like you have some extension where you had some original context IDs and then you want to update them. Now you have a whole set of new context IDs. And if you've already chained them earlier with some other ones, you now need to redefine all of those too. And like, or like if you want to have this particular extension, then you want to stop using it, then you want to start using it again or combine it with a new thing, you have to like keep updating your whole set of context IDs. And there's just like a lot of state potentially there. And if you get out of sync, it may be unclear which set of combos the both sides know about.
I mean, if you get out of sync, if you see a context ID that you just don't know, you have to do whatever you do with context IDs you don't know. You delay
Sure,
the
but-
packet for a while, then throw it away. It's the
Yeah,
only
but
thing
I
you can
guess it's
do.
just like
Yeah.
it's just yet another piece of information. Like so, like you may have independently, or the other side may have already received all of the individual bits that to know about the new state, but they haven't received what is the context ID for the cumulative combination of them. Anyway, so like
I didn't think
yeah.
about the implementation complexity here, but like the one thing that's very obvious is, of course, the bits overhead, right? And like here you have an overhead in every packet, and
Sure.
the other one you have to send like a whole bunch of capsules from time to time, but you don't probably send them that often. So that's a clear difference.
Right. And I think, you know, we've had this discussion in the working group before. I would lean towards maybe having the, like actually look at like, what is the actual byte overhead? Can we tolerate it? But I think it's a lot easier to reason about some of these cases. It also depends like how frequently you have them, right?
I just wanted to say it depends on the extension, right? If you
Yes.
don't know what the extension is, you don't know how frequently you would change it.
Right. Because I think with this model, like you would essentially end up defining like there are types of capsules that can be prefixes that can just, this is additional information like, hey, this thing had a ECT1 marking on it and it's kind of infrequent and like just slap it on the front and then otherwise we don't worry about it. And then there are terminal capsules, which are probably always going to be like the UDP payload or the IP payload. And so I think for that model, it can work well. But yeah, if you have the exact same marking on every single packet, then it's more annoying. But I still think it's like easier for cases. I guess it's all easier for cases where you want to be able to change the marking. You're not just doing the same marking for all the packets and you like never change what your fields are going to be.
But I mean, also, for all those cases where you only want to use one extension, nothing will change, right? It's just like all those packets where you have to combine more than one extension. And in case of ECN, you could say it's actually not all the packets, just like few of them.
Right. So as a compression apparently enthusiast, I obviously strongly support sending more capsules or bigger capsules rather than eating into MTU. So it feels to me that option 1 is still preferable. Now, when it comes to explosion of capsules and context IDs, well, the implementers should be reasonably smart and define if we have a parent-child relationships, so that we have parent context ID and multiple child context IDs that depend on that, we could just ideally send things that change less frequently as the parent and things that might change more frequently, like, for example, ECN or smaller things as the child. So we could maybe have some text around it.
So I think the point is here actually that if we decide we go for any of these solutions, I think it would actually, and I don't want to make this overly complicated because we were punting on this point earlier, but I think it would be good to kind of make the decision for all the extensions we do, because then you have the same mechanism and then you can actually decide if you want to chain one on the other or the other way around, right? So then it's just an implementation decision.
Absolutely.
Yeah, so this is my, no, I mean, this is not the last slide, but this was the last slide. We would like input, but we would also like to get the draft adopted.
I see Sahad.
Yeah, thanks for the presentation, Maria. I mean, maybe I didn't get one thing that I was looking in the draft. Maybe I misunderstood the things. So, I mean, now we can do ECN. We can also say like, okay, you can do ECN DSCP. But perhaps the proxy want to do one of the thing, like DSCP only. It doesn't want to do ECN. So how does it tell? What does it do? I mean, is it like it doesn't really provide any ECN information with the same capsule?
No, so you could save 2 bytes if you really want to optimize for that. But not doing ECN means the IP header code point is always 00. And so the ECN DSCP option just provides you the whole byte. And so the ECN bits have to be always 0. And that's all what to do.
So, I mean, basically, we are saying like, if you're, I mean, I kind of read through that one. It is not that clear in the document. Maybe we should do that kind of thing. I was going to open an issue, but I think I got the answer. Thank you. And yeah, I have another point. So this is basically, I mean, the proxy when you're doing this, any of these extensions, is for both upstream and downstream traffic. So if you're, or like, what is the direction of this thing? You expect like, okay, this is for...
It's independent, so both of the
Yeah.
sites can just tell, I want to use ECN. Yes.
Yes, okay. Yeah.
Or DSCP.
So Gore, just as a confused individual,
Like
this
always.
is all sending 1 byte, which doesn't usually change, and maybe 1 bit in that byte changes. And we have this huge repertoire of stuff. So I feel like maybe this is about something much bigger, as in how we do extensions rather than how we do ECN and DSCP, which seems easy.
Yes.
And are we, I kind of read it, but then I got confused by all the options. Are we aiming that any receiver will be able to pick up any combination that the sender sends? Or are we...
You mean combination of what?
Well, I mean, are we expecting the implementer to do all the, whatever the patterns we choose, so that we can just send the other end the packet? Or are we going to be setting up the context ID and making sure that the implementation is supportive for whatever we're doing?
So I'm not sure I understand your question, but the answer might be that to use these extensions, any of them, you also need to negotiate them. That's why you need the header as well. So you can, of course, only combine those that you negotiated and both sides understand.
Yeah, I'm trying to look at what the failure mode is when we get that wrong. But the failure mode is we throw everything away because we don't have the context.
Yeah. So I totally agree that this kind of combining different extensions, we need to think through it carefully from the beginning to the end. But I think we need it.
Hi, Altnai Okay, thank you. Altnai Siskumaraki. Was there any intention of having harmony between the QUIC outer tunnel and the inner flows at all? Because I see that this could land into a situation where there is conflict and then there are performance implications.
For ECN, you mean?
Correct.
I think the normal tunnel recommendations for ECN apply, but we have some discussions there. So it depends if your tunnel is congestion controlled or not. If your tunnel is congestion controlled, you would consume the outer ECN bits directly for your congestion control, and you wouldn't put them in the inner packet. If you are a tunnel, like traditional tunnels today that are not congestion controlled, then you have to like put the marking into the inner packet before you forward it. But then normal tunnel considerations that I think have been specified in the area apply. And there's some discussion about this in the draft, yes.
Okay, thanks.
Thank you.
Hello, Chris Box, BT. So just a general comment. I think it's really cool that you're working on this problem of how do we enable L4S for a MASQUE proxied connection. When I looked at the draft, I found it, possibly because I'm not so close to this work, coming to it as someone relatively unfamiliar with it, I find it difficult to comprehend what exactly is being proposed. There are no diagrams that say we're going to do this and we're copying from this to this. There's something in section 6.3, I think, about how do you use this, but ideally I'd like to see more helpful text in there or diagrams that explain how this is supposed to be used. It does refer to 9599 and which is, I think Bob was an author of that, and yes, that did help me understand a bit more about what we're doing here and the feed forward and up and things. But I think ideally, yeah, it'd be good to have some explanation in this document if possible.
Sure, we can look into that. Yes, we were concentrating on the specification, but some guidance
Yeah.
makes sense. Yes.
Thank you.
This is regarding some clarification question here. So you are trying to standardize the ECM plus DSCP within the context ID part. But there are some organizations who's going to override, basically use that one to define their own context ID between the, in that session part.
Yes.
So if you got the unfortunate case, they got the same context ID, how to handle that case?
So I'm very unhappy that 3GPP took this route and they are negotiating context IDs out of band. We told them if you do that, you cannot combine them with any other extension, and that's what they
So
are at.
basically you said you just go ahead to standardize here without consider something has been standardized or has been done already.
So they should have standardized their extension here. Then we can combine extensions in the way that is a standardized way. And they can still do it. So I'm happy to have this work here.
Yeah, I know, but the things are supposed the vendor has implemented the feature, on
Yes,
the
but
mobile
this was when we had the discussion in 3GP, we brought up the point that you cannot combine this way with new extensions, and they accepted that. So that's the case. You cannot combine it with this extension, unfortunately.
Okay. You don't like it? Yeah, talk to your colleagues.
I mean, it's that just means you can't use new extensions, right? So it doesn't end the world, but it's very sad.
Okay, thank you for that discussion. I think that was very helpful for the authors. We're going to ask the same question that we asked for the compression draft. So first of all, have you read it?
Actually, I sit down, right?
Sure. Yeah. Okay, so that's stabilizing at about 11. I've read the draft. 22 no, which means the other half of the room either have no opinion or presumably have not read the draft. I think we're going to, again, follow up with that on the list, but I think there's some useful discussion here that gives some very good feedback for both drafts for the authors. So thank you all. And that was MASQUE IETF 124. try and grab Tommy's point that the negotiation mechanism should really be done here. I think is persuasive, but it's about the only persuasive thing I think other than taking these drafts to a different group. But that's about the only reason I can think of, other than taking the drafts to a different group, where they would just have more eyes and more pressure to some extent.
I don't think any group would be acceptable.